Hello and welcome again. This type of question normally comes towards the end of any exam, mock or real, and it's a modelling question. Modelling with vectors. I'll read up to part A because it will take a long time to even read out. A gas company maintains a straight pipeline that passes under a mountain. The pipeline is modelled as a straight line and one side of the mountain is modelled as a plane. There are access ways from a control centre to two access points on the pipeline. Modelling the control centre as the origin O, the two access points on the pipeline have coordinates such, where the units are in meters. A. Find a vector equation for the line PQ, giving your answer in the form of R is equal to A plus lambda B, where lambda is a scalar parameter. Let's deal with that first. So we've got to find a vector equation for the line PQ. So that's Q minus P, and we're going to use vector form 300. 300 is Q and minus 50. So that's the point Q, because PQ is going to be Q minus P, and we're going to minus P, which is minus 300, 400, and minus 150. And what does that give us? Well, that's going to give us 600, 100, and of course 100. So this is what I'm going to call B, which is our scalar parameter in R is equal to A plus lambda B. So R is therefore equal to, again I'm going to write out minus 300, 400 and minus 150 as my A, and plus lambda B, which we've just found, plus lambda and B, which is 600 minus 100 and 100. And there is part A for 2 marks. Now, we have to, so let's just write A here, because this is A, and I've got me 2 marks already, so I'm going. Now, you need a point on the plane from the pipeline. You need, I'm going to write this out, explain what I'm doing. You need a point from let's have, you need a point, how do I write this, on the plane, on the plane from the pipeline, excuse my writing. We need any point from the plane, on the plane from the pipeline, PQ. So we're going to draw that later. We need to put, and we need to read on as well, we need to put X, Y and Z, because it says the access way will consist of a tunnel of shortest possible length between the pipeline and the point M, 100, K and 100 on the side of the mountain where K is a constant. B, using model, find 1, the coordinates of the point at which this tunnel will meet the pipeline, and 2, the length of this tunnel. So we need an X, Y and Z, which is, and I put which is what M is. M, which is 100, K and 100, into, and we're going to subs that into 2x, now plus 3y, because I need to find the value, so I'm going to call it K. So plus 3k minus 5z is equal to 300. So I run out of space there, but that's what I'm just saying what I'm doing so that I can find what k is. So if I substitute my values are found 600 minus 100 and 100, what do I get? I've got 2x, so subs x is equal to 100, and yeah, I've got 3k. So I'm going to substitute x and z, and y I would leave as k. So substitute x and z, substitute xz found from, of course, that's 600 minus 100, so 600 and 100. Yeah, yeah, that's right. 2x. So and I got 2 times 100. 2 times 100. Sorry, m is 100 and 100. So we're going to find k. So we're substituting m, the value of m. Apologies. We're substituting m, not b. We're substituting m 100 and 100. So this is what we're going to substitute in here, this and this, and we're going to find k. So substitute x, y, and z. So I need to change that. Apologies, all in real time here. We do make mistakes sometimes, but we correct ourselves. So substitute x, y, and z, and that's for m, x, y, and z. So that will give me 2 times 100 plus 3 times the value of k plus 5 times, or minus 5 times 100, which is equal to 300, because that's what we're doing. We're using this here. Yeah, and where y is equal to k, given y is equal to k here. So that will give me 200 plus 3k minus 500 is equal to 300, and that will give me 3k is equal to, well, that's going to be 800, 1,000, yep. So 500, 800 plus, minus 200 is 600, sorry. So we got 500 plus 300 is 800 minus 200, that gives me 600. So k is equal to 200. Okay, so I found the value of k then. So now if we do a little construction, I've got my point m somewhere. So m is going to be, if I write it in vector form, that's going to give me 100, 200, and 100. Okay, and we'll put a little cross here, and let's do our construction. Let's do the line PQ. Okay, and let's call that PQ. And let's draw a line. It's got to be a perpendicular, of course. So, and it, oops, I don't want it in black. I want it in a different color. Yeah, let's have red. Oh no, that's too thick. Let's go back. And I'm conscious of time here, so I gotta. Okay, that's probably better, because it's a big question. Let's go again. Okay, so we're going to, oops, let's go back, and we're going to want to bisect intersect that line at right angles, because we want to draw a perpendicular. Okay, we'll leave it like that. Can I move that slightly? Yeah, okay. And alright, that's good enough. And let's move on. We need to change our color again. Let's go back to black. Okay, so now I'm going to call this, because we need to find the coordinates. It's asking me to find the coordinates of that point where it intersects the plane, or PQ. So let's call that point an unknown point, and dear, we've got to get a little bit better organized here. Okay, let's go back to a nice one. Okay, so let's call that point X, this point M, and it does talk about a central point, modeling the control center as the origin. The two access points on the pipeline have coordinates. Okay, so we need a central point which they call the origin. So let's call this point here O. So we got OMX, and so PQ is the pipeline, and M is a point on plane. So PQ is our pipeline, and M is our point on plane, the plane. Haven't drawn a plane, but it's just a flat object, which is perhaps not the most sensible thing, but you know, it is what it is. So we need to find where the perpendicular meets the pipeline, and its distance. So we need to find the coordinates and the distance of the perpendicular, and of course the control center is O. So we need the vector, really, we need this vector, mx. So let's just join up this point, these points. Can I? Yep. One here and one here. Yeah. So there we have it. Let's go back to that and make sure that, yeah, okay, good. Right. Okay, so let's get going again with the math. So we're going to go back to some GCSE stuff now. GCSE vector mx is, if I go to MO, and then from MO to OX, I'm going to get mx, the vector. So mx is equal to MO plus OX, and that will give me mx equal to what is it, minus 100, minus 200, minus 200, minus 100, and plus OX, which is minus, because this way, by the way, you're going the opposite way, so everything's going to be negative. So minus 300, 400, and minus 150. Minus 150. And I've got to add lambda times, of course, 600 minus 100 and 100. Okay, we're getting there. So mx then, mx is equal to, well, I've got 600 lambda minus 400, minus 100 lambda minus 100 lambda plus 200, and 100 lambda minus 250. Wow, what a question. And I've got to multiply that by 600 minus 100 and 100. Oh, to avoid big numbers, I'm just going to divide everything through by 100. And if I do that, I'm going to end up with, let's just write it again. So mx, let's just say what I'm doing, divide through by 100. I end up with 6 lambda minus 4, minus lambda plus 2, minus lambda plus 2, lambda minus 2.5, minus 2.5, yep, and multiply that by, oh that's nice, 6 minus 1 and 1, and that looks a lot tidier. I mean, you can go to your calculators, of course, but this gives me what, 36 lambda minus 24, that doesn't look like a 2, minus 24 plus lambda minus 2 plus lambda minus 2.5 equals 0. And I get 38 lambda is equal to 28.5. 28.5, and therefore lambda is equal to 3 over 4. Wow, lengthy question. Now I've got to substitute, so I'm still saying what I'm doing, lambda to find OX. Substitute lambda to find the vector OX. Yep, so if we do that, OX, the vector OX will be equal to, and you can go back to check, I'm conscious of time, so because we've taken so long, it's a lengthy question, it's at the end of the exam and I'm probably running out of time. Oops, made a mistake here. Minus 150, yep, so that's OX, which is XO, and then plus 3/4, and 600 minus 100, 600 minus 100, and 100. And that gives you 150, 150, 325, 325, and minus 75. Okay, we're still getting there. So part B, oh, and that's, I leave it in vector form. That's the answer to part B, part 1. Part 2, the distance, so B part 2, the distance will be found by the distance mx, so distance mx will be, using Pythagoras, equal to the square root, and again I need to say what I'm doing, 150 minus 100 all squared, plus 325 minus 200 all squared, yep, 200 all squared, and finally add minus 75 minus 100, minus 75 minus 100 all squared. So, and that will give you 220.8 meters. So that's the distance mx. Going back to our diagram. So this distance here, and of course m was these coordinates. That's what I'm substituting in, and that should be look like a 200. Okay, so that's what I'm substituting in the theorem associated with Pythagoras, I should be saying. Now we need to find out whether or not this company should build the accessway. Well, in order to do that, we got to look at, and I've taken 20 minutes so far, that's a long time to answer a question, OP and distance OP and OQ. Well, OP, so the modulus of OP is equal to, and I've got to put in all the values here, it's 300 squared plus 400 squared plus 150. So oops, 150 squared. Plus 150 squared, which is equal to 522 meters, which is bigger than 222.8. So OP, what about OQ? OQ is equal to, well, that's going to give me 300 squared plus 300 squared plus 50 squared plus 50 squared, and that gives me the value of 427.2. Now just going back to check these figures, yeah, they come from P and Q there, so that's what I'm substituting in, and this is what we found. Now both of these figures are greater than 220.8, so it's sensible to build. Sensible to build. I'm going to write that. Sensible to build accessway. To build the accessway. To build as greater than 220.8 meters. Now, finally, a limitation, because I want to finish at 23 minutes. That's a long time for just 12 marks. A limitation of the system. Well, we're talking about modeling a plane for a mountain. So just one limitation for the model. When you model a plane as a mountain is not flat, so a plane may not be a good model. A plane may not be a good model, or is not a good model, may not be a good model, oops, a good model for a mountain. Good model for a mountain. For 1 mark, that's enough. And sorry to take so long.